In this lesson, we're going to focus on simplifying radicals. So let's say if we have the square root of 36, the square root of negative 49, negative square root 64, and negative square root negative 25. How would you simplify these four radicals? The square root of 36 is simply 6. It's a real number. The square root of a negative number is not a real number. It's an imaginary number. So this is equal to 7i, where I is the square root of negative 1. If you haven't learned about imaginary numbers, you can not worry about it. So this doesn't give you a real number, it gives you an imaginary number. But the way you show your work though, here's what you can do. First, separate the 49 and the negative 1. The square root of 49 is 7, and the square root of negative 1 is I. So you get 7i. The square root of 64 is 8, but there's a negative in front, so it's negative 8. Now for this one, we have negative square root 25 times the square root of negative 1. The square root of 25 is positive 5, and the square root of negative 1 is I. So the final answer is negative 5i. Now you need to be familiar with the perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and then 36, 49, 64, 81, and 100. I'm only going to go up to 10 in this video, but you may want to know it up till 20. 20 squared is 400. Now, let's say if you want to simplify the square root of 75. What would you do? Now, this is not a perfect square, but what I recommend doing is to break down 75 into two numbers, one of which is a perfect square. So looking at the list of numbers that you see here, which of these numbers go into 75? 75 is a multiple of 25. If you divide 75 by 25, you get 3. So 25 times 3 is 75. Now the square root of 25 is 5. And so that's how you could simplify a radical like this. The square root of 75 is equal to 5 square root 3. Now let's look at some more examples. Because you want to master this technique, so I'm going to give you a lot of examples to practice on. Go ahead and simplify the square root of 18 and the square root of 48. The best way to learn is by practice, so you may want to pause the video and try these problems yourself to make sure you understand this concept. So what perfect square goes into 18? 9 goes into 18 two times, so I'm going to write 9 times 2. The square root of 9 is 3, so the square root of 18 simplifies to 3 square root 2. Now let's do the same for 48. What perfect squares go into 48? 4 can go into it, and 16 can go into it. When you have two perfect squares that can go into 48, you want to choose the larger of the two values. 48 divided by 16 is 3. So you want to break down 48 into 16 and 3. The square root of 16 is 4, and so it simplifies to 4 square root 3. Try these two problems. Simplify 8 square root 80 and also 5 square root 98. So the square root of 80, how can we simplify it? If you're not sure what to do, take 80 and divide it by each perfect square. 80 divided by 4 is 20. 9 does not go into 80. 80 divided by 16 is 5. And 25 doesn't go into 80. So the highest perfect square that goes into it is 16. So I'm going to write the square root of 80 as the square root of 16 times the square root of 5. Now the square root of 16 is 4. And now at this point, all we need to do is multiply 8 by 4, which is 32. So the answer is 32 square root 5. Now for the next one, what perfect square goes into 98? 49 is half of 98. So we can write it as 49 times 2. The square root of 49 is 7. And 5 times 7 is 35. So we have 35 square root 2. And this is the answer. Now, if you're asked to simplify this fraction, 5 divided by the square root of 2, what can you do? All you can do in this problem is rationalize the denominator. And to do that, multiply the top and the bottom by the square root of 2. So on top, you can have 5 square root 2. On the bottom, the square root of 2 times the square root of 2 is the square root of 4, which is 2. So your final answer is 5 square root 2 divided by 2. So for the sake of practice, try these two examples. So for the first one, let's multiply the top and the bottom by the square root of 3. The square root of 3 times the square root of 3 is the square root of 9, which the square root of 9 is 3. So this is the answer. And so for the last one, we're going to do the same thing. Now the square root of 5 times the square root of 5, we know in the end it's going to be just 5. The square root symbols will cancel. And so you get that as the answer. Now you need to know what to do when adding and subtracting radicals. So for example, how can we simplify this expression? 4 square root 8 plus 3 square root 50 minus 6 square root 32. Now think about how we simplified the square root symbols or the radicals individually. So think of a perfect square that goes into 8. 4 is the highest perfect square that goes into 8. So I'm going to write 8 as 4 times 2. 25 is a perfect square that goes into 50. So I'm going to replace 50 with 25 and 2. And 16 goes into 32, so I'm going to write it as 16 times 2. Now the square root of 4 is 2. And the square root of 25 is 5. The square root of 16 is 4. And now we need to multiply. 4 times 2 is 8. 3 times 5 is 15. And 6 times 4 is 24. So now we can add the coefficients. 8 plus 15 is 23. And 23 minus 24 is negative 1. So it's negative 1 square root 2, which is the same as negative square root 2. So this is the final answer. Here's another example for you. 7 square root 27 plus 3 square root 12 minus 5 square root 48. Go ahead and simplify this problem. So 9 is a perfect square that goes into 27. 27 is 9 times 3. 4 is a perfect square that goes into 12. And so 4 times 3 is 12. And 48 is 16 times 3. So it helps to know your multiplication values. Now the square root of 9 is 3. And the square root of 4 is 2. The square root of 16 is 4. Next, multiply. 7 times 3 is 21. 3 times 2 is 6. 5 times 4 is 20. And now let's combine the coefficients. So 21 plus 6 is 27. And 27 minus 20 is 7. So the final answer is 7 square root 3. So now you know how to add and subtract radical expressions. Now let's say if you have this expression 8 divided by 3 square root 2. How can we simplify the expression? If you have a fraction with radicals, it might be wise to multiply the top and the bottom by the conjugate, in this case, of the denominator. So the conjugates can be the same thing, but instead of a minus, we're going to have a plus in between the 3 and the square root of 2. So on the top, we got to distribute the 8. 8 times 3 is 24. And 8 times the square root of 2 is simply 8 root 2. On the bottom, we need to FOIL. 3 times 3 is 9. And then we have 3 times the square root of 2. And 3 times negative square root 2. And then negative square root 2 times square root 2 is just negative 2. Now the two middle terms, 3 and negative 3, adds up to 0. So right now we're left with 24 plus 8 square root 2 divided by 9 minus 2, which is 7. So you can leave your answer like this, or you could separate it into two fractions. You can write it as 24 divided by 7 plus 8 over 7 square root 2, if you want to. But that's how you could simplify the expression that we had. Let's work on another example. Simplify this one. 3 plus the square root of 2 divided by 5 minus the square root of 2. So what should we do? The best thing to do is to multiply by the conjugate of the denominator. That is 5 plus the square root of 2. So let's FOIL on top. So we have 3 times 5, which is 15. And then we have 3 times the square root of 2 plus 5 times the square root of 2. And then the square root of 2 times the square root of 2, that's just 2. On the bottom we have 5 times 5, which is 25. And then 5 times the square root of 2. And then 5 times negative square root 2. And finally, negative square root 2 times square root 2, which is just negative 2. So in the denominator, 5 and negative 5 adds up to 0. So they're going to disappear. And then we can combine 15 plus 2, which is 17. And we could also combine 3 plus 5, since they share the same radical. So 3 plus 5 is 8. So we have 8 square root 2. On the bottom we have 25 minus 2, which is 23. So the final answer, we can write it as 17 divided by 23 plus 8 over 23 times the square root of 2.